So in the previous video, we discussed the average value of a function. In this video, we're going to go ahead and calculate the average value of a function. So the example says find the average value of f of x equals x cubed minus 2x plus 2 over the closed interval from 2 to 4. And then what we want to remember from the previous video is that the average value of the function is just the area under the function. Sorry, that's this piece right here. It's the area under the function divided by the length of the line segment over which you found the area. So 1 over b minus a is the same as dividing by b minus a. So we're going to go ahead and set this up. We want to find the average value. So the average is going to equal, and it's going to be 1 over the length of the line segment over which we're integrating. So that's going to be 1 over 4 minus 2 times the integral from 2 to 4. So we're going to find the area under the curve on the closed interval from 2 to 4. So this is going to be x cubed minus 2x plus 2 dx. So this is going to equal 1 over 4 minus 2 is just a half. And then remember, the fundamental theorem of calculus says that to calculate this definite integral, we need an antiderivative of the function. So an antiderivative of x cubed is going to be 1/4 x to the 4th minus an antiderivative of 2x is just going to be x squared plus an antiderivative of 2 is just going to be 2 times x. And we're going to evaluate that over the interval from 2 to 4. So this is going to equal 1/2 times the fundamental theorem of calculus says now plug this upper bound of integration into the antiderivative. So we're going to get 1/4 times 4 to the 4th minus 4 squared plus 2 times 4. And then the fundamental theorem of calculus says to subtract from that the result that you get when you plug the lower bound of integration into the antiderivative. So it's going to be 1/4 times, it's going to be 2 to the 4th minus 2 squared plus 2 times 2. And then it's just a matter of simplifying things. So it's going to be 1/2 times, this is really going to be 4 cubed right here. And 4 cubed is just 64. 4 times 4 is 16 times 4 is 64 minus, and 4 squared is 16 plus 8. And then we're going to have minus right here. And 2 times 2 is 4. Divided by 4 will go away. So we're just going to get a 4 out of this. 2 to the 4th is 16. Divided by 4 is 4. Distributing the minus sign into the parentheses here, I'm going to get minus, minus, plus 2 squared is 4. And then minus plus is minus. 2 times 2 is 4. And then this is going to equal 1/2 of, and then we just start simplifying things as much as we can. So I'm going to have the 64, and this is going to be minus 16 plus 8 is minus 8. Minus 4 plus 4 is 0, so this will be minus a 4 here. So this is a half of 64 minus a 12, which is just a half of 64 minus 12 is going to be a 52. And then a half of 52 is going to be a 26. So there's the average value of the function. And if we're asked to find the average value of the function, we're just after the left-hand side of this relationship right here. So this time it didn't say to find the value of c for which the function equals its average value on that interval. If we were asked to find the value of c for which the function output matched the average value of the function on the interval from 2 to 4, we would have to take the original function and set it equal to the average value of the function. So we would wind up taking the x cubed minus 2x plus 2 and setting it equal to the 26, and you would wind up getting an x cubed minus 2x, and then we would subtract that 26 from both sides. We'd have minus 24 equals 0. And what I want to recognize, the reason for going just a little bit further with this, is now you've got to find the roots of a cubic polynomial. And then if you haven't made a mistake here, which is always a possibility, if there are 3 roots, because it's a cubic, there may be 3 zeros. At least one of those zeros, if you haven't made a mistake on this calculation, should lie on this interval. But notice a cubic polynomial isn't in general easy to solve. So just because the value of c exists for which the function is equal to its average value doesn't mean that c is easy to find. And in this particular case, it probably isn't going to be easy to find unless this matches a special case where it's easy to factor or you can guess easily. So anyways, average value of a function, that's just the left-hand side of the relationship. You're not being asked to find c, the value for which the function equals its average.